Hi, I'm Mark Breen. Welcome to this ongoing series in astronomy featuring the motions and rhythms of the heavens, changes that we see in the sky. We started in the series talking about the motions of the sun, something pretty easy to observe, but certainly something that changes over a measurable amount of time. That that part I always think is kind of fun. Now the stars, you know that they change because if you go outside at different times of the year, you do see stars in different positions. You see certain groups during, say, the winter or the summer and not at the other times of the year. So that motion we talked a little bit about over the past couple of sessions, and we're going to still talk a little bit about the motions of the stars, but in this case, we're talking about motions that take place over such long periods of time that in general, you're really not going to see this. You're not going to notice these changes. So why are we talking about them? Well, they actually are changes that we have noticed, we being humans, but we've noticed them over hundreds or thousands of years. And this actually has had an effect on the stars that we see and a little bit on how we think about the sky. So we'll be reviewing how we've been looking at the sky so far, and then think about how those changes take place over long periods of time, what that means to what we see. So we're going to start with how we usually start. We're going to think about what you can go outside and observe. And so to help us out with that, we're going to review a little bit about something that we talked about the last time, having to do with what you can see in the sky, especially thinking about the sun in the sky. So we'll just give you a little view here. We're going to change our image so that you can see the position of the sun against the background of stars. This is a nice chart. You can see some of the details. You've got just two examples, but you can start to get the sense that if you take June as a starting point, where you are on the Earth, if you look where the sun is in the sky, of course, you're not going to see the stars, but against that background would be the stars of Taurus the Bull. On the other side of the Earth, on the opposite side, we would see the stars you would notice in the nighttime. So when the sun is in the constellation Taurus, or appears to be in front of those stars, then you would see the stars of Scorpius or Ophiuchus, which you can see on the bottom of the picture. A few months later, as the Earth goes around the sun, our orbit changes where we see the sun against the background of stars. The stars didn't move, we did, but it does change where the sun appears in the sky. And in this case, in August, it appears to be in front of the stars that we call Cancer the Crab. On the opposite side of the Earth, so in other words, the nighttime sky, constellations like Sagittarius and Capricornus would be featured. So this is the idea that as the Earth goes around the sun, it changes where the sun appears against the background of stars. That entire group of stars is known as the zodiac constellations, sometimes more familiarly as the horoscope. A lot of us know perhaps the sign that we were born under, that type of thing. And you can see as the Earth goes around, that is how it changes. Now, at the same time, this is how it appears today. But we are talking about things that change over a long period of time. One thing that we probably should think about is as the Earth is going around the sun, it changes how we see the stars. And of course, the Earth is tilted on a bit of an axis or an angle. So let's just take a look at this image where you can see the sun positioned in the stars of Virgo and Leo. And at the same time, on the night side of the Earth, you can see the constellations Pisces and Aquarius appearing in the nighttime sky. If we go 6 months later, so essentially the sun is on the other side of us as we would see it. Again, the Earth is obviously doing the actual motion, but this is how it appears in our skies. Again, we're thinking about observational astronomy. And so you can see the sun is now positioned in Pisces and Aquarius, where we saw it during the nighttime sky 6 months earlier. And that also means that the nighttime sky is different, with the star constellations Virgo and Leo appearing during the nighttime sky. Some of these motions and so forth have been observed for hundreds or even thousands of years. Now, in terms of what we're seeing for motion, we really don't see much of a change from year to year, decade to decade. In fact, the stars, as they've been described, are pretty much the same way we've described them for thousands of years, going back to the ancient Greeks. And yet, even in that time, in the time of the ancient Greeks, one of their very diligent, kind of amazing astronomers, was named Hipparchus. Hipparchus spent a lot of time being very precise in his study of the stars, and in fact had published kind of the first list of stars and their approximate brightnesses. He was the first one to do that. This was over 2,000 years ago. In the process of doing that, he was looking at the position of the star Spica in the constellation Virgo, the Virgin. It turns out that this star was very close to the sun's position on the fall equinox. One of the things that he noticed was looking at earlier records from other Greek astronomers several hundred years earlier, the star Spica had appeared to move. So he continued to observe, taking a look at the older records and noticing what he was observing. What he found out was that the star Spica had shifted its position by a noticeable, measurable amount during the period of time of the Greeks. And so we're talking about a period of about, somewhere in the neighborhood of 200 or 300 years. They did not have precise records, but what he noticed was a movement of about 2 degrees. Now, 2 degrees, maybe that doesn't sound like a lot. To give you an idea of how much that is in the sky, the moon is about the width, or about a half a degree in width. So in order to get 2 degrees of motion, that's the width of 4 moons side by side. Now that's a noticeable, measurable amount of change. And that's what Hipparchus noticed. And so since Spica was near the time of the equinox, the time when the sun was at its point really above the Earth's equator, the days and the nights are in balance. That's where the word equinox comes from. But what that means is that he was noticing the equinox changing or shifting. And so he called this the precession of the equinox. As it turns out, it's not just the equinox that's changing, but it was a good first start in terms of what he was thinking about, how the sky was changing, not absolutely constant, but something that was slowly changing. And they were trying to understand this. One of the things that the Greeks were confident about is that although the sky might change, there was going to be some purpose, some particular rhythm, some kind of cycle that they would be eventually able to measure. And indeed, that was one of their goals. Now, this is talking about changes that we can see over long periods of time, something that you really would have a difficult time measuring during your lifetime. We do have more precise measuring instruments these days, so it certainly is possible. One of the ideas here is that the sun changes where it's positioned during the different key points of the year. So thinking about the first days of each season, first day of spring, summer, fall, and winter. And as that changes, it's going to change not only what we see in the sky. Obviously, if the sun's in a different constellation, let's say in the first day of summer, it means that the summer skies are going to be different. And they continue to change very slowly over long periods of time. And that's kind of our point here today, thinking about those longer period changes. So one thing to think about is there are 12 constellations that we call the horoscope or zodiac. These are the constellations that the sun appears to move through. And so if there are 12 of them, we know that in a circle, there are 360 degrees. If we divide it into the 12 constellations, each constellation has 15 degrees of sky. Now, if we think back to Hipparchus's measurement, he noticed that the star Spica had shifted 2 degrees over about 200 years, or about a degree every 100 years. Closer measurements and more refined measurements today show that that change actually takes place over 71.6 years. It's a little fussy, but that's exactly what astronomy is about. Nevertheless, it means that the sun would shift against the background of stars by approximately 1 constellation in these zodiac constellations, about 1 every 1,500 years. Since it takes 100 years to change 1 degree, 15 degrees would take 1,500 years. So this is a long-term change. Again, nothing that you and I are going to notice, but it does change how the sky appears. So this motion actually has to do with more than just a change in the sun's location in the sky. It turns out it has to do with the Earth's axis actually wobbling around. So as you look at this image, you can see the Earth on the left and then a spinning top on the right. Why? Well, you've probably seen this before. A spinning top, as it slows down, begins to wobble, as we say, and it causes that axis that it's spinning to start curving around in a circle. Perhaps you've seen this before. Here's an example using a gyroscope. You can see how the gyroscope spins, and yet at the same time, at least in this image, it's not falling down. The Earth isn't going to fall down, but this is what the Earth's axis is doing. It's actually making a pivot, a very slow pivot, and it takes place over long periods of time. Now, think about that, and you can see in this illustration, the Earth's axis is going to be pointing at different stars over different periods of time. Now, again, this is a motion that's going to take place over thousands of years. So we need to determine a little bit better what that looks like and how that changes our view in the skies. Thinking about the position of the North Star. So this is a chart showing some of those changes, but we're also going to look at how you can actually view it in the sky. But we'll start with this, and you can see at the top the star Polaris, our familiar North Star. And you can see a plus 2,000. That means 2,000 years after the year zero. Now, technically, there isn't a year zero, but that's okay. The idea is here in the year 2000, we have Polaris as our North Star. And it's actually been the North Star for hundreds of years and will be for hundreds of years more, but not forever. This does change. And in fact, in about 2,000 years ago, where it says plus 4,000, so it's a little bit to the left of Polaris, now that line, that kind of orangish line, will be positioned very close to a completely different star. It's a star near the top of the constellation Cepheus, the King. We will have a different North Star. Now, at some point, we've got to change from Polaris over to this North Star. We've not really done that in recorded history, so it's a little hard to imagine how we're going to determine that or who's going to make the decision to say, okay, we're now switching. But it is something that will change over thousands of years. And in fact, as you look at this chart, you can see that this change continuously takes place. Remember, the Earth spinning on that axis, and that axis slowly pivoting around means the North Star will gradually change over a long period of time. So in another 2,000 years after that, then the North Star will be, or the North Pole will be aimed at the middle of Cepheus, the King, no particular star, very close to that line. And then as we get to about the year 7,500, at that point, that brighter star in the lower part of Cepheus, the King, will be the North Star. So you can see it continues to change. And in fact, if we go to the opposite side of the sky from where Polaris is, so in about 12,000 years, so 12,000 plus 2,000, 14,000 years, you can see a brilliant star near the bottom. That is going to be the brightest North Star that we ever get. Of course, you'll have to wait 12,000 years, but at that point, a star named Vega. Now, Vega is one of the brightest stars in the sky, the fourth brightest that we can see, but it is going to be the North Star a long, long time from now. Something to look forward to, I suppose, but you can see where it's positioned. And now you can see some negative numbers. I guess one way to think about this in a historical sense is the North Star has been changing in historical times. So let's go back to the top of the chart for just a moment. You can see Polaris plus 2,000. If we go to the right, you can see the year zero. And then if we go back a little bit more, we get close to a star named Kokab. Kokab was really the North Star that the Greeks thought about. And in fact, you can see it's not very close to that line. Therefore, it's not perfectly lined up with the Earth's axis. And as a result, Kokab and the star just below it were often called the guardians of the pole. They seem to guard the polar region in the sky. If you go back farther, though, around 3,000 years BC, there is a star and it's marked there called Thuban. Thuban is in the constellation Draco the Dragon. It's kind of in the middle of his tail. It's not a terribly bright star, although it was right along that line. 5,000 years ago is about the same time that the pyramids were built in ancient Egypt. In ancient Egypt, this star was their North Star. So does that change how things are lined up with the pyramids? Not really. The North Star is the North Star. It's still going to be in the same position relative to what we look outside and see. It's just that the entire star field appears to change because the Earth's axis is slowly moving around. So it's a fascinating thing that changes place over thousands of years. And speaking of thousands of years, about that same time, 5,000 years ago, people in ancient England were thinking about the stars and started the first constructions of Stonehenge about 5,000 years ago. Well, that's a way of looking at some charts, but now I thought it'd be a little bit more interesting to actually view it in the sky. What do we actually see? So we're going to change programs here. We're going to look at our program that we know as Stellarium. So let's make this image just a little bit bigger here. So we'll expand this. So now we can see the star field. In fact, I've selected the star field that you would see during the month of May. And we're looking toward the south. It's a little bit after 9 o'clock in the evening. This is what we can see. Notice a bright star is mentioned here, known as Arcturus. It is one of the brightest stars in the sky and turns out to be the brightest star in our summer sky. In the south, we can see a bright star here, and this is the star that we were talking about earlier. The star's name is Spica. If I click right on that, you can see up on the top left here, it says Spica. Is another word that's another Arabic word for it, but Spica is the name that most of us know it by. Now, Spica is in the constellation Virgo, the Virgin. So here's the line drawing, and you can see Virgo here. The star Spica means a spike or a stalk of wheat. This would be her back, her neck, her head is up here. There's a front arm right out here, and two legs extending out this way. So there is Virgo, and there's the star Spica that Hipparchus used over 2,000 years ago to realize that the sky was slowly shifting. So how can we see that in our skies here? Well, one of the things that we can do with this program is we can change the date. Now, there are a couple of things that we want to see. So one of the things that doesn't change in terms of the sky is something known as the celestial equator. So this is the Earth's equator projected out into space. And we can actually show that to you. We'll add that line in here. That blue line is the Earth's equator projected out into space. Notice it runs exactly from east to west. And that's an important consideration because no matter where we go in terms of orbiting the sun, that shape stays the same in terms of its location in our skies. It always extends exactly from east to west. Now, the other line that we're going to feature here is the path of the sun. We had seen that before in terms of a chart, but now we'll take a look at it in terms of the skies and a couple of star groups to notice. We have Leo the Lion up here and a bright star that's almost perfectly on that line, a star named Regulus. Regulus is the brightest star in Leo the Lion. It's right on that line. Notice that as it appears now, it sits above the celestial equator. Spica is below the celestial equator. In fact, since Spica has been the one changing, and it used to be near that point where the sun would be located on the equinox, that would be where these two lines meet. So that is how much this star has changed in its position over a couple of thousand years. Now, since it's moving in this direction, maybe you can kind of estimate what star is moving toward this location. Did you guess Regulus? I hope you did. There it is. Everything is moving this way. Now I can tell you that, but let's see if we can actually demonstrate that. So we need to change the time, but I think it's more helpful to see that. So we're going to add our window over here. You can see the date and time has popped up. We're going to move that out of our view so that we can still see the stars. And you can see the year listed here, 2020. So we're going to change that time. Now, it turns out we can advance time in lots of different ways. And so in this case, we're going to advance time by tens of years. And you can start to see that. Let's just advance it 10 years. And if you look, so we're going to keep the date the same. So we're going to stay in the middle of May. We are also going to go forward 10 years. Now, lots of different ways to do that. Let me just show you. You could actually change the number here. You could go in and highlight it with your cursor, and then the number 3. And, oh, did you see much change? Not really. There really isn't much change in 10 years. And in fact, if we go forward another 10 years, another thing you can use is the page up or page down keys on your keyboard. And if I use the page up, we've gone forward to 2040. Now again, there are some changes. We can see the moon is suddenly in view. We've got Jupiter in view. We've got Saturn in view. But those stars, Spica located here and Regulus located here, they haven't changed at all. Or they haven't changed in a noticeable amount. So let's now go forward in time a little more quickly. And you can see not much change yet. Is there going to be a change? Well, we've only gone forward about 120, 140 years. Well, let's stop here at 150 years. So it probably has changed a very tiny amount, but 1 degree isn't going to change how we see the sky. So even 150 years from now. So we need to change time more quickly. So we are going to speed up that change. As we do, you can see the sky is changing. Look at the star Regulus getting closer to that blue line. See if we can stop it right about there. So I've stopped, but look at the date. It is now the year 4250. So we've moved forward 2,230 years. That's a long time in the future. So in 2,230 years from now, the sun will be in the constellation Leo the Lion on the first day of fall. That's very different than where it is today. So you can see there are changes that do take place over longer periods of time. Notice also that the star Spica is positioned even lower in the sky. So let's think about that, especially as we look on the other side of Leo the Lion, the constellation Cancer the Crab, and Gemini, the twins. This is the location of the sun on the first day of summer today. But if we go forward in time, we're going to advance time again, so that time is now moving along very quickly. Notice that the twin stars of Gemini, I'll just stop for a moment so I can point out the twin stars of Gemini, they will continue to move, gradually shifting toward the blue line. Again, that is the point at which we would be at the fall equinox, the first day of fall. And you can see Gemini continuing to move. In fact, they're now moving below that line. We've now moved forward. It is now more than 8,000 years into the future. And we're going to move just a little bit more into the future so that we can really get a good sense of that change. So we did mention that the brilliant star Vega would be the North Star in about 12,000 years from now. And so I'm just moving a little bit slower, more forward, so we can get to the year 14,000. That was one of the years we mentioned. Now, before we look at the North Star, let's also look in the south here, and we'll try to identify some constellations. Now, this is the month of May. So now let's change that. We've been talking about the year, but let's change the month. So we're going to go forward in terms of months. This is May. We're going to increase that to June, July, August. So here we are in the middle of summer. And one of the things that I want you to notice is Gemini in the middle of summer is very low in the sky. That is not at all where we see Gemini or how high we see Gemini, what time of year. We see Gemini during the winter months. Here we see it in the summer months, 12,000 years in the future. So it crosses the sky very low in the sky in the summer months, completely different than what we see today. If we continue forward in time, this is in August, so September, October, November, December. Whoops, I'm still in November, hang on. December, I want you to look high in the southern skies, high above the Earth's equator projected out into space. We see, and Mars just happens to be in this location in the year 14,010 in December, but notice we have a constellation called Scorpius. That is the scorpion in the sky, which we normally see in the summer months. But here we are seeing it in December. Again, we're thinking about how the Earth's axis gradually pivots around. So it is going to change the sky over thousands of years. And this is just a good example of that. Now seeing the scorpion instead of in the summer months, seeing it in the winter months. So we've been talking about how we can see the sky during the summer in the south. Let's now change our view. Let's swing around into the northern part of the sky, and we'll leave the time in the year 14,000 well in our future, but we're going to pivot the sky around and swing around into the north. And where is that North Star? Well, as we stop here in the north, look at the brilliant star Vega that we talked about. It's not exactly on this line, but this line is the line that we saw earlier that marks the position of the North Pole over that long, long period of time. And so right now, it is closest to the star Vega. Now this circle is a little bit confusing, so we're going to change that a little bit. Instead of having that image up, and I just need to go to my menu to let that disappear, so click that off. But instead, we are going to show you a view that you do not necessarily see in the sky, but this is something that certainly makes sense in the sky. This is the grid pattern, which is centered at the North Pole where it's positioned in our sky. So this is exactly above the North Pole, and you can see Vega here. Now let's watch as we go through the course of the night. We're going to watch Vega in its motion. We're going to speed up time here. And you can see Vega is staying in the north, pivoting around this location. So that's what's going to make Vega the North Star in 12,000 years from now, in the year 14,000. Vega will be the closest star to that point exactly above the Earth's equator. So Vega will remain in the sky all night long. And as it turns out, it has some interesting companions that will keep a company, so to say, over those nighttime hours. All through, we can see very close to Vega, the bright star Altair, and we can also see the star Deneb. The three stars all together are known now as the Summer Triangle. I wonder what they will be called in the year 14,000, because it'll be seen in the summer, but also in the winter, spring, it'll be seen all year round. It will be always and permanently in the sky. So we will have perhaps just simply the Great Triangle of the sky, the Great Triangle of the North. Maybe you can come up with a potential name, but this is how the sky will change over that long period of time. So we did have that image up earlier showing the progression of the stars during a long period of time. So let's take a look at that now. We're going to let the stars kind of stop. Well, let it stop right about here. And let's return that image. This shows the path of the North Pole across the sky. And so let's just add that image back in here. So let's see where that circle is. Well, its position drops down very close to the northern horizon. It's kind of disappearing behind those trees. So we're going to advance the sky here just a little bit. And let's bring our time window back up so that we know here we are in December. So let's change that so we can get that circle up so we can see it a little bit. So let's move into, well, let's use May as an example, since we are in the month of May. And now let's again change time over long periods of time. Well, I guess we probably should return our time stamp window right over here. And so we're looking in the year 14,000. And by the way up here on the circle, but not near the polar region in the skies, this is the current day's North Star, Polaris, located up along the line, but obviously not in the north. So let's see how that changes. You can see it's the only other really bright star that's on this line. So let's just let time progress once again here. So as we do so, let's focus in on this time here, and let's watch this change. So I just need to click on this just one more time. Oh, it's behaving a little bit differently. Hang on just a second. And let's get it moving forward in time. And so maybe we need to highlight this. There we go. Well, it changed the time a little bit more sharply than I wanted. Let's go back to the year 14,000. Okay, and there's Vega very close to the line. There's Polaris up here. And now we, oh, it's definitely not liking this. Let's redo this one more time. So we'll go back to 14, the year, let's change the time on here so that we can go to the year 14,000, and we'll just add another, few years. That's fine to see it there. We also need to change this back to May, and that's fine. And we'll change this. So we're looking at a nighttime sky. All right. So now that we have it here, let's change the date, the year. We're going to do that by going forward. And you can see now it's changing by 10 years. And let's continue to go forward, and we'll speed time up. And so what I want you to look at, here's Vega. Here's the North Star that is the present day. So let's see how this changes over thousands and thousands of years. And you can see Vega is slowly moving away from that point. And if you look at the circle, it's gradually pivoting around so that the North Star is heading back toward that point in the sky. So in some ways, I suppose, as time goes forward, we will eventually repeat what we've seen. This indeed is the idea with these long-term cycles in the sky. You can see the North Star is getting closer. And so this will give us an approximate idea of how long it takes this cycle to complete one turn around. And so we're almost there. You can see Polaris getting very close. Let's stop it right there. And let's look at the date. If you look down here, you can see it's the year 27,000. That's right, that's the year 27,010. So that is 25,000 years from now. And that's very close to the calculated amount of 25,700 years that it takes the Earth's axis to spin around one time. It's an amazing thought to think that those changes take place over such long periods of time, but it does affect where we see things in the sky. So a great thing to consider. Next time, we're going to change back to some things that we can observe, something you'll notice quite easily, even during the course of the summer and fall. We'll be talking about the motions of the planets in the sky next time on Motions and Rhythms of the Heavens.